Hello, today we are going to discuss about TCP/IP protocols. So in this we will learn about various protocols like TCP, UDP, ICMP, IGMP. So let's start with these protocols. First is Transmission Control Protocol. This is the main protocol of the Internet Protocol suite. So that's why the entire suite is referred to as TCP/IP. So TCP provides reliable, ordered and error-checked delivery of a stream of bits between application running on user device. So internet applications such as World Wide Web, www, email and file transfer rely on TCP. This all works over the TCP. This represents the TCP header. It is of 32-bit and contain various fields. So let's discuss about this in detail. The first field is source port. It is of 16-bit and it represents the source port number. And destination port, it is also of 16-bit and it represents the destination port number. Whereas sequence number, it is 32-bit and it is used for numbering TCP data segments or adding sequence numbers. Acknowledgement number, it is of 32-bit and that indicates the sending device is expecting a next sequence number from the other device. Next is data offset. It is also known as header length field, or it's define the length of the header field. It is of 32-bit and the minimum size header is of 5 word and this field is held by the user. So reserved. Next is reserved bit. It is of 6-bit and always set to the 0 and it is reserved for the future use. Next is control bits. It is of 6 bits and control bit manage the entire process of connection, establishment, maintenance and termination. These bits are URG, urgent pointed field, PSG, push function, SYN, synchronized sequence number, ACK, acknowledgement field, RST, reset the connection, FIN, finish, no more data from sender. So these are the control bits. Next is window. It indicates the size of the receive window that the receiver is currently willing to receive. So it specifies the number of bytes to be received in the acknowledgement bit. Then is checksum bit. The checksum field is used for the error checking of the header field and data. It is of 16-bit long. And the urgent pointer. When the URG bit is set, the urgent data is given priority over other data stream. So it is of 16 bits and show the end of the urgent data. Next protocol is UDP, User Datagram Protocol. UDP is a simple connectionless transmission model. So it uses minimum number of protocols for data transmission. The UDP provides checksum for data integrity and port numbers for addressing the packet in the network. But there is no guarantee of delivery, ordering or duplicate of data packet in the network. This represents the UDP header, consists of source port, destination port, UDP length, UDP checksum and data. So let's discuss about this. UDP header consists of 4 fields, each of 2 bytes in length. Source port. It's 16 bits and indicates the port number of source device from where data originates. And destination port, it indicates the port number of destination device where the data have to be sent. Next is UDP length or the header length. It defines the length of the header and the encapsulated data. So the minimum value of this field is 8 byte. Then is UDP checksum. It is used for error checking of the header field and the data. And this field is optional in IPv4 addressing and mandatory in IPv6 addressing. So next protocol is ICMP, Internet Control Message Protocol, which it is used in Internet Protocol suite. So ICMP is used by network device like routers to send error messages and operational information. But the difference between ICMP and other transmission protocols such as TCP and UDP is that it is not used for exchanging data between systems in the network. It is only used to exchange error messages or the optional information between the routers or the switches. So these represent the header of the ICMP. It consists of ICMP type, ICMP code, ICMP checksum and ICMP content. So let's discuss about this. The ICMP header starts after the IPv4 header. So ICMP packet have an 8-byte header and variable size data section. The data section is of variable size. Type. The type field indicates the type of the ICMP packet. This is always different from ICMP type to type. These types are like echo reply, echo request, destination unreachable, redirect message, trace route, timestamp. These are the type of the ICMP. So this field is of 8-bit. Code. All ICMP types have different codes. Some type only have a single code while the other have several code. So this field is of 8 bits in length. Checksum. The checksum is a 16-bit field used for error checking of the header fields and the data. Whereas ICMP content, this is of variable size and it contains the user data. Next is IGMP protocol, that is Internet Group Management Protocol. The Internet Group Management Protocol is a communication protocol and it is used by hosts and routers on IPv4 network to establish multicast group memberships. And IGMP is also used for networking applications such as online streaming, video and gaming. IGMP is used on IPv4 network. This is the header of IGMP, consists of version, type, code, checksum and group address. It is somewhat same as that of the ICMP header. First is version, which is of 4-bit and it indicates the type of version of IGMP package, that is V1, V2 or V3. And type. It indicates the type of IGMP packets. Example, type 1 for create group message and type 2 for create group reply and so on. Next is code. It is of 8-bit and it indicates the IGMP packet code related to the type of IGMP packet. Different IGMP type have different codes. Next is checksum. The checksum is the 16-bit used for error checking of the header field and the data. Whereas group address, it is of 32-bit and in a create group request message, the group address field contains 0 and in all other request messages, the group address field contain a host group addresses. So this is all about protocols. Thank you.